Section of Chapter 1 is Section 1.6, Scientific Notation. So we need to learn how to convert from standard notation to scientific and from scientific to standard. And we want to learn how to deal with that pesky E on your calculator. So recall that the place values and the relationship to powers of 10. Power of a 10, so starting with ones, that would be 10 to the 0 power, which is just 1. And then tens would be 10 to the 1 power, which is 10. Hundreds is 10 squared, which is 100. Thousands is 10 cubed, which is 1,000. Going to the right of the decimal, we get 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, etc., which would be 0.1, 0.01, and 0.001. So you're just moving, every time you add, change the exponent, it's moving the decimal. If it's negative, you're moving it to the left. If it's positive, you're moving to the right. So if you're discussing very large numbers like the mass of Mercury, which is a really large number, I don't even know what that is, compared to Jupiter's, which is another very large number, or a very small number like the length of a red blood cell as compared to the length of a white blood cell. If you write it in standard form, you could spend more time counting the zeros and wrapping your heads around the relative size of the numbers than actually doing anything interesting with that information. So this is where scientific notation comes in, and it allows us to write very large or very small numbers in a way that's easier to comprehend and compare. So scientific notation for a number is in the form a times 10 to the r power, where a has to be between 1 and 10. It could be equal to 1, but it can't be 10 or larger. So that's really a big key that students often forget. R is in any integer. It can be positive, negative. So when converting to scientific notation, we keep moving the decimal point until we have a number greater than or equal to 1 and less than 10. That is, there should only be one digit and not 0 in front of the decimal point. The number of places we move the decimal point will correspond to the exponent of the power on 10, where you can determine its sign as described below. So example 1, looking at the powers of 10 in their decimal form summarized in the table above, complete each of the two sentences below with the appropriate phrase, large number greater than 1, or small number between 0 and 1. When a number written in scientific notation has a positive exponent on its power of 10, the standard form of that number must be a very large number and it is greater than 1. When a number written in scientific notation has a negative exponent on its power of 10, the standard form of that number must be a very small number, and that's between 0 and 1. Example 2, looking at the powers of 10 in their decimal forms summarized in the table above, as well as your answers to 1a and 1b above, complete each of the two sentences below with positive or negative as appropriate. Therefore, if we're trying to write a large number greater than 1 in scientific notation, we know the sign of the exponent on the power of 10 in scientific notation will be positive. So large numbers greater than 1, your exponent's positive, and then small numbers between 0 and 1, the exponent is negative. All right, so now to actually converting, we want to convert each number in scientific notation. So I want to move this decimal, I'm going to zoom in here, until I'm at a number between 1 and 10. So 1, 2, 3, 4, 5. Right here, I'm at 1.5, which is between 1 and 10. and I had to move 5 times. Wait, 1, 2, 3, 4, 5. So this would be written as 1.5 times 10. Now I moved 5 times, but it's a very small number, so we're going to make it a -5. Example B. I need to move until I'm at a number between 1 and 10. So I'm going to do big hops here. I'm going to go by 3s, 3, 6, 9, 12, 15, 18, 21. So it's 1.899 times 10 to the positive 21 because we have a very large number. So again, 1.899 is a number between 1 and 10. All right, let's take a scientific number and write it in standard form. So I take this 5.753. I'm moving the decimal 4 times to the right because it's a big number. 1, 2, 3, 4. I need to add a 0, so the answer is 57,530. And example B, I take this, I'm going to write it over to the right, and you'll see why, because I need to take this decimal and move it over 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And now each one of these, oops, I wrote that in the wrong place. Each one of these little hops is a 0. So I'd get 0.00000033. In other words, there's 7 zeros in front of the number. Now, when you get very large or very small numbers in your calculator or on a computer, oftentimes it'll give you something like this, and you're like, what the heck is that? It is just scientific notation. 1.13e to the -5 just means 1.13 times 10 to the -5. So you could write that as 0.1234 zeros, 113. There's always going to be one less than the exponent because you have one going just to get it in front of the number. If that doesn't make sense, just go back and look at example 4b, where it was -8, but there ends up being 7 zeros in front of the 3. So that is what this means when you get that in your calculator. That might come up on occasion, so keep that in mind.